Okay, dear students of class 6, once again let us see chapter 3, playing with numbers. So today we will start a new concept, that is tests for divisibility of numbers. Now how can we say whether a number is divisible by any other given number or not? So in order to know quickly whether a number is divisible by the other given number or not, we need to know this divisibility test. So which is called tests for divisibility of numbers. First one, by 2. So how can we say that whether a number is divisible by 2 or not? By 2, if you want to see whether a number is divisible or not, then digit in the unit or ones place should be either 0, 2, 4, 6 or 8. Example 350. So here is 0 in the ones place. 9172. So 2 in the ones place. Here is 6 in the ones place. Here is 8 in the ones place. So all these numbers, they have 0, 2, 6, 8 in the ones place. So all of them are divisible by 2, because in order to be divisible by 2, the ones place digit of the number should be either 0 or 2 or 4 or 6 or 8. So always look at the ones place digit whenever you want to test whether a number is divisible by 2 or not. Then divisibility by 3. Sum of the digits should be a multiple of 3. That means if you add all the digits of that number, like we have done here, all the digits of that number are added and we got 24. Now 24 is divisible by 3. That's why we can say that 78,234 is divisible by 3. Next, divisibility test by 4. Number formed by last 2 digits should be divisible by 4. For example, like the number is 73,512 and the number formed by the last 2 digit is 12. That's why 12 is divisible by 4. Hence we can say that this whole number is divisible by 4. Here last 2 digit is 20. So 20 is divisible by 4. Therefore 9520 will be divisible by 4. Here last 2 digit 00. So when the zeros are there, then if 2 zeros are there, we can say that the number is divisible by 4. Next, by 5. Last digit should be either 0 or 5. Like here we have 0, here we have 5. So both of these numbers are divisible by 5. Next, by 6. Number should be divisible by both 2 and 3. That means whichever number you are testing by 6, then that number you have to test by 2 as well as by 3. So that number should be divisible by both 2 and 3. For example, 4572. We know ones place is 2, that means this number is divisible by 2. Now we have to test it by 3. So we will have to add all these digits. 5 plus 4 is 9. 9 plus 7 is 16. And 16 plus 2, 18. And 18 is divisible by 3. That's why we can say that this number 4572 is divisible by 6. Similarly here, it is divisible by 2. And if you add all the digits, you will find that 7 plus 3, 10, 8 plus 2, 10, so 10, 10, 20, and plus 4, 24. So 24 is divisible by 3. So we can say that this number will be divisible by 6 also. Now by 8, divisibility test of 8. Number formed by last 3 digits should be divisible by 8. For example, 2104. Now number formed by the last 3 digit is 104. Now you divide 104 by 8. If it is divisible by 8, 104, then we can say that this whole number 2104 will be divisible by 8. So we saw here 104 is divisible by 8. So that's why 2104 is divisible by 8. Now here 45,136. number formed by the last 3 digit is 136, so you test it dividing by 8. Now we will see that this is divisible by 8. That's why we can say 45,136 is divisible by 8. Then next divisibility test is that of 9. Divisibility test of 9. Sum of the digits should be divisible by 9. It's just like that of 3. Now if you add all the digits of that number, then the sum, after adding what you got, that is the sum should be a multiple of 9. That means it should be divisible by 9. So here in this case we saw, if you added 4, 5, 6, 8, 4, we got 27, and 27 is divisible by 9. That's why we can say that 45,684 will be divisible by 9. Now divisibility test of 10. For 10 it is very simple. The last digit should be 0. Like here you have 0 in the ones place, here you have 0 in the ones place, so both these numbers are divisible by 10. Then divisibility test of 11. For 11 you have to do a bit of calculation. Here difference of the sum of alternate digits of the number should be either 0 or a multiple of 11. What does it mean? Difference means subtraction and sum means addition. So we have to do both the things here, add and then find the difference of what? Like example 13673. Now alternate digits means 1 plus 6 plus 3, you will add one side, remaining 3 plus 7 you will add on the other side. Then we saw that the result of this is 10, result of the others is also 10. Then you subtract now, that is called the difference. 10 minus 10, we got 0. So if we get 0 as our answer, or any multiple of 11, like if you get the difference as 11, or if you got the difference as 22 or 33, then we can say that that particular number is divisible by 11. Now we will see the exercise. Okay, let's see exercise 3.1. State true or false. So first question, number A, all natural numbers have minimum 2 factors. That is the statement. All natural numbers have minimum 2 factors. So it is false, because we know 1 is also a natural number which has only 1 factor. But according to statement, it was all natural numbers have minimum 2 factors. So first one is false. Number B, all prime numbers have only 2 factors. All prime numbers. So you should know the definition of prime numbers as given to you already. Numbers having only 2 factors are called prime numbers. According to statement, you are given all prime numbers have only 2 factors, so it should be true, because numbers having only 2 factors, 1 and itself, are called prime numbers. So that is true. Number C, all prime numbers are odd. So this is false, because 2 is a prime number, but it is even. So according to statement, we had all prime numbers are odd. 2 is the only prime number which is prime as well as even. 2 is even. So number C is false. Number D, a composite number is always a product of 2 prime numbers. So it will be false, because given is a composite number is always a product of 2 prime numbers. So if you take for example 8 is a composite number because it has more than 2 factors. So it is a composite number 8. Now the factors of 8, a pair of factor is 2 into 4. So 2 into 4 we saw 2 is prime but 4 is not. Again, if you take another composite number 12, so we have factors like 3 into 4 where 3 is prime but 4 is not. Again 2 into 6 is 12 where 2 is prime but 6 is not. That's why the statement is false. because the statement says a composite number is always a product of two prime numbers, and we saw that it is not always. There may be one prime and the other composite. Next, number E. There are natural numbers which have no factor at all. Number E. There are natural numbers which have no factor at all. So it will be false, because 1, a natural number, they are all counting number. The first one is 1. 1 is the smallest natural number. So if we see the factor of 1, at least one factor is there of 1, then rest all will have either 2 or more than 2 factors. So even 1 has one factor, and we call it a unique number. So statement is false, because the statement says there are natural numbers which have no factor at all. That means no factor, zero factor. Okay, then number F. A composite number has minimum 3 factors. A composite number F, it is true. A composite number has minimum 3 factors, not less than 3. Because if it is less than 3 factor, then it will be a prime number. It will no longer be called a composite number. So a composite number has minimum 3 factors. So 3 or more factor are there in a composite number. So it is true. Like if you take example of 4. 4 has the factor 1, 2, 3. 4 is a composite number and it has 3 factors. So minimum 3 factors should be there in a composite number. Then number G. A prime number can be even. Prime number can be even. That is true, because 2 is a prime number which is even as well. Then number H. The sum of two prime numbers is always prime. The sum of two prime numbers is always prime. You can think about some example like 3 is a prime number, 5 is a prime number, 3 plus 5 we got 8, but 8 is composite. 7 is a prime number, 3 is a prime number, 7 plus 3, their sum we got 10, and 10 is composite. But the statement says the sum of two prime numbers is always prime. So it is false, because the sum of two prime numbers we get composite as also. So it is false. Now coming to question number 2. You had find the factors of. So finding of factors in class 5 also you had done 76. Now divisibility test we had already seen just now. So divisibility test has to be applied. 76. First, 1 is a factor of every number, so 1 into 76 will be 76. Then since in 76 1's place is 6, so it will be divisible by 2, 38 times. Then by 3 you add the digits. 7 plus 6 is 13, and 13 is not a multiple of 3, so 76 is not divisible by 3. Then 4. By 4 it is divisible, 4 19 times. By 5 it is not. So this way if you test, then we see that these are the factors 1, 2, 4, 19, 38 and 76. So the factors of 76 are 1, 2, 4, 19, 38 and 76. Similarly, now number B, 312. 312. So beginning with 1. 1 is a factor of every number, so 1 into 312, then 2, because 1's place is 2, that's why it will be divisible by 2, 2 into 156. Then by 3, yes, if you add 3 plus 1 plus 2 we get 6, and 6 is divisible by 3, so this number will be divisible by 3, 3 into 104 times. Then by 4, number form by the last 2 digit is 12, and 12 is divisible by 4, that's why we can say that this number is divisible by 4 also. Now 4 how many times? We can find out on the rough side. 4 78 times. Then by 5, 1's place is 2, it is not 0, it is neither 5, so it is not divisible by 5. By 6, yes, it is divisible, because it was we saw that already divisible by 2 and 3. Those numbers which are divisible by both 2 and 3, they are divisible by 6 also, so 6 52 times. Then by 8 it is divisible, by 12 it is divisible, by 13 it is divisible. So these are the factors of 312, which are 1, 2, 3, 4, 6, 8, 12, 13, 24, 26, 39, 52, 78, 104, 156 and 312. Now finally question number 3, find the first 5 multiples of 11. So it is very simple. Multiples means multiplication table, and there is no end to multiples, but that's why we are asked to write only the first 5. So the first multiple is the number itself always, because 11 one time is 11. So first 5 multiples of 11 will be 11, then 2 times 22, 3 times 33, 4 times 44 and 5 times 55. So we got 11, 22, 33, 44 and 55. So this question number 1, 2, 3 I have shown you, and now question number 2 and 3 you will do the rest, 2 and 3 rest part as homework. Okay, thank you.